All right, in our second types of solutions, our intro, we are also looking at solubility. We are going to look at some different compounds. So between ionic and covalent, when you dissolve ionic compounds, and we're thinking of a solid ionic compound in water, most likely. Solutes will dissociate into ions for ionic, which means the positive and negative ions separate and they're free to move independently. This is called dissociation. Now, in covalent, solutes may stay, or they stay as molecules, so they don't separate. Sugar molecules separate from each other as they are surrounded by water, but they do not break apart, is what I meant by they don't separate. So they separate as molecules, but they don't break apart further into anything else. So they do not dissociate. Ions become hydrated because each becomes surrounded by water molecules that are attracted to them. If you take a look at the picture here, we just have our sodium chloride. Notice that the water molecule, or oxygen, which is the more electronegative atom, is going to be attracted to the sodium. So it orients itself closer to the positive charge, whereas chloride, your hydrogens are going to orient closer to that. So it surrounds those ions and it breaks apart, like tears them apart. Molecules become hydrated because each become surrounded by water molecules. There is something called a hydrate, and these are ionic substances that form crystals with water molecules. So, for example, this is called copper 2 sulfate pentahydrate, since there are 5 water molecules that are attached. As far as other properties, remember ionic can conduct electricity. An electrolyte is an ionic substance that dissolves in water to make a solution that can conduct an electric current. So electrolytes conduct electric currents. For example, sodium chloride. Now covalent cannot conduct electricity. This is a little review from last unit. A non-electrolyte is just the opposite. So it dissolves in water, creating a solution that cannot conduct an electric current. An example would be sugar. So anything molecular or covalent. The strength depends on how many dissolved ions it has. So a very strong electrolyte means it has lots, like almost all of a dissolved compound forms ions. So lots of ions present means you have a strong electrolyte. If you were to test this in your conductivity tester, it would shine very brightly. A weak electrolyte is going to conduct electricity poorly. It's still conducting, but only a small amount of dissolved compound forms ions. So if you were to use like that light bulb conductivity tester, it would be a dimmer light. And covalent doesn't form electrolytes, so there's nothing on that side. Here's a picture of, for example, the different types of conductivity. We have, for example, sodium chloride. That's going to give you a really good bright light because it conducts well, because it has a lot of dissociation, lots of ions, many. Whereas ammonium hydroxide only dissociates partially, so it has a lot fewer ions. So it's going to be weaker, it's going to be dimmer light, and then obviously sugar. That's what glucose, for example, that's a non-electrolyte solution, no conductivity. All right, some factors that affect solubility. This is kind of intuitive since we're like all kind of used to trying to dissolve things. Like say in your kitchen, you're trying to dissolve some sugar. Like how can you get that to dissolve faster? Well, one thing we can do is change the surface area of the solute. The smaller it is, the more surface area to volume it has, and so therefore it's going to dissolve faster. If you agitate the solution, shake it, stir it, that's going to help it, give it some kinetic energy, more opportunities for that solvent to be brought into contact with the undissolved solute. You could heat the solvent, so that will increase the kinetic energy as well. And most solutes increase in solubility with increased temperature. Sometimes they don't, depending on what type they are, but most of the time. And Ke stands for kinetic energy. Now, we're talking about solids here. If you're talking about gases, that would not apply. If you heat the gas, actually it's going to go the opposite way, it's going to decrease the solubility. This is called a solubility curve, and you can figure out the different solubilities, the different amounts of solutes that are soluble at different temperatures. You'll notice like this one, sodium chloride, is pretty plateaued. The other three substances they gave us are all salts. Mostly, they have different rates, solubility, but most of them are increasing with increasing temperature. So it just shows you the different temperatures and different amounts of solute dissolved. So here's the solubility curve again. And we'll use this for determining the difference between saturated, unsaturated, and supersaturated solutions. If, you are below, say we're looking at this blue curve of sodium chlorate, and, at 40 degrees, the saturation point would be like approximately 100. So that would be like a saturated solution. If it was below, it would be unsaturated. And if it was above, it's supersaturated. Pressure changes, this really only affects gases. So pressure is not going to affect solids because solids are already very close together. So pressure is going to change or affect gases. The higher the pressure, the more soluble the gas. There is something called Henry's law, which just means that as the solubility of the gas is directly proportional to the partial pressure. So as we increase pressure, we increase solubility. We decrease pressure, we decrease solubility. It's just a direct relationship. And the last thing I have here is just a couple-minute video on the difference between supersaturated, unsaturated, and saturated, and then I have the definitions of those. Okay, so types of solution based on saturation. Here's some pictures, and then also hopefully the video helped a little to introduce it a little bit. All right, saturated means that we have a solution containing the max amount of dissolved solute at a given temperature. So we are at capacity as far as how much solute can be dissolved. If you keep adding more and more, it's just going to sink to the bottom and just start piling on there. So saturated solution is the maximum amount. Supersaturated is kind of cool because it's a very temporary, unstable state. So super means above saturation. So it contains more dissolved solute than a saturated solution in the same conditions. And what will happen often is if you heat it to a very high temperature, more solute will dissolve in theory should. And then when you let it cool and you disturb it a little bit, it'll crystallize. So when it comes back out as crystals, then it's saturated again. And then lastly, unsaturated just means we can put more in. So it's below its max capacity.